So when it comes to data analysis, there tends to be this spectrum of either using and leveraging Google Spreadsheets or Excel, or on the other end, we have tools like Python, like Jupyter Notebook, or like any other alternative, or like going directly with SQL or R, Scala, Spark, whatever. The the perspective I kind of want to show you here, and it's a little bit not really on the spectrum that I mentioned, it's a little bit different perspective altogether. So the idea is that in most cases, when we actually want to deal with data and we have some model, some interesting process that we want to model, get insights out of, is we care more about like the packages of data, the elements and the relationship than the particular value of it. So for example, as if we were doing with Excel, so like with the particular cell was representing the particular value. So in this case here, and this is the application I try to like show already, so you might be familiar with it. The idea is more or less that we model the process as a graph. So each one of those elements here has its name, has its formula. The formula is basically the description of like a transformation from the dependencies. So that, for example, here volume depends on the demand shock and the data that we load as a units measurement. So the idea here is that we don't really want to bloat the representation of data. At this particular moment, we don't really care about it. We care more about what is happening with it, what it describes, how it relates to our process. And we do it by, on this left side, you see here, we have this whole documentation panel. You can think about it as like a semantics of the model. So it's not necessarily related to like particular values of it, of the data that we have underneath it. It's more about like what this data is, what the unit of it is, like who changed it, why, what it relates to, what is it based on, if it's like available, deprecated, etc. And then when we actually go to the right side here in the value preview, we see the representation, the actual representation of data that is underneath it. So for example, in this case, because we have the large tensor, like three-dimensional tensor here, we are just showing some statistics. So like the range of stuff, or like maybe like some coordinates, etc., or like the axes that we have described there. But if you go to particular like single scalar values, it's just it's just available there. You can just view it, see it, and use it. So that's like from the process perspective and from the perspective of like how we think it should be like it's a little bit easier to think about this whole like process modeling is that you have those really distinct and separate steps that you go through. So basically right now I'm showing you the model. So this is basically this description of the transformation. So like formulas, descriptions, rationales, units, and dependencies that you see here, like what's dependent on what's using which data. But that's semantics. So that's like a function that we define. But if we go step earlier, we actually also need to base our computations on the data. So we need to have this whole idea of loading tables. So we can either upload them as a CSV, we can also create them manually. I'm not going to go through this as of this moment, but once we have the data table, we can actually then think about so it's, for example, this Excel file with all the like inputs of like maybe like stock changes or like some currency discrepancies, etc. Whatever like your domain data might be, and then based on that CSV, that table, you are able to create the measurement itself. So this is the measurement we call a table that is built from this input table from some basically from any arbitrary tabular input, and then we can also like transform it, for example, pivot on particular columns so that we achieve this multidimensional data. So for example, here we see that we have those three axes like SKU, region, month that we pivot against, and those will give us those three axes in the result. but the values themselves come from this fourth column, and we just take them as they are. So that's basically the idea. We can also like skip particular columns if we have really large input table, but the general idea is that we import the data. On that imported data, we then create a measurement, so particular transformation that gives us that data available in the model. So if you then we jump here to the model, we see them here at the top as available. And then once we have it, you probably noted it already, we have those dice icons here. And basically they represent that this element in the whole process is dependent on the, let's call it like randomness overall. So basically, if you read a little bit closer, we have this notion, we have this ability to model distributions here and how they affect the whole model, the computations themselves. And the idea is that if we have something that is like, for example, the normal distribution, and then we multiply something by it, we will see those changes if we run them as a simulation, like multiple times. And the idea then is if we have this model, if we know how they relate to each other, what the units are, what is dependent, what is constant, what is actually varying during the analysis, we can actually run it. We can actually have like Monte Carlo simulation run multiple times and get insights into particular elements, how they change in that simulation. So for example, here we can see all the P10, P90, etc., all the statistics related to also that particular shape of data. So if it's like a single value over like multiple trials, or if it's actually a vector, if it's actually like a multidimensional. So it's all there. It's all like available. It's not like necessarily, you don't have to script it yourself. You don't really have to build any apparatus around like your usual processes to get those insights. It's just that you focus on the really core important questions. And basically, the first question is how the process looks like. So this is here in the model, and what data you want to run it against. That's here in the data. And then you run the analysis and you get all those insights almost like by default. So you just run it, wait for the results, look at the graphs. Maybe something is interesting, something's not. You can then tweak the model, see how they differ, because we have whole history here on the right side. And it's all there, it's all available. It's like fairly intelligent in terms of like what we can show against what at, and like how to actually represent it so that it's useful. Um, Yeah. So maybe on like a last note, maybe last comment here. I noted it already like in the beginning here, but we have this duality, right? So we have, it's not just that it's combined together, that we have data inseparable from the semantics of the transformations, of the semantics of the model. We have a model that if we care about, we can separate from the data and, for example, share with someone. So we can do it here through just going here, downloading it, and it will just allow us to get that particular model, its semantic representation, so not the data, but just the shape of it, the units, the descriptions, so basically all the, let's call it like domain knowledge of it, domain representation of it. And then we can go ahead again, for example, like for the, like if we want to share it with our client, or if we want to share it with like a second company that we have, we can just import it. They can use it, but they would still have to provide their own data to it, right? So that's the idea behind this, and that's the idea that it's not really the idea. It's like just this separation between those three phases. So data, modeling, and analysis. This is what we get as an option, as a possible solution overall. So yeah, I think that's pretty much it in terms of the application and how it works. So if you have any questions, if you want to know more how it works internally, just let me know. If you want, I can dive a little bit deeper into the technicalities and how the application came to be, and what we do to make it actually work. fairly like reliably and fast, let's call it, so that we don't like over compute stuff and like just make it sluggish. But yeah, it's up to you. Let me know. Thanks.